Hi! Welcome to the Earthquakes and Megacities Initiative webinar series. My name is Ann Siders, and today I'll be talking to you about climate change adaptation and disaster risk reduction. Today we'll provide two lessons. First, we'll provide a background on climate change and how climate change will affect natural hazards in your work as disaster risk management professionals. And second, we'll discuss some tools that you can use to incorporate climate change into your work. Today's webinar will be split into two sessions. In the first, we'll provide the climate change science and background, then we'll have a question and answer period and a short break. In the second section, we'll come back and discuss the tools to integrate climate change adaptation, and we'll have a second question and answer session, and that'll wrap up today. All right, let's get started. The Intergovernmental Panel on Climate Change has these things to say. Warming of the climate system is unequivocal and unprecedented. We've already observed changes. The atmosphere and ocean have warmed, the amount of snow and ice have diminished, sea levels have risen, and concentrations of greenhouse gas in the atmosphere have increased. Furthermore, the IPCC notes that the human influence on the climate system is clear. I use these quotes because I want it to be clear from the beginning that climate change is real, climate change is occurring, and we are causing it. These things are not uncertain in the scientific community. Climate change is happening, and we need to begin to address it. So what is uncertain about climate change? It's the greenhouse gas emissions that we might see in the future. Greenhouse gas emissions depend on my behavior and your behavior, and our society and how we use fuel sources and electricity and how we consume these. The IPCC looks at over 40 different emission scenarios. This graph just illustrates 3 and the different implications they could have for our future weather. Here you see a lower emission scenario, a higher, and a highest. And note that between now and 2100, these have very different consequences for our global temperature. At the lower scenario, we see an increase in 4 degrees Fahrenheit, whereas in the highest emission scenario, we see an increase in 8 degrees Fahrenheit. That's a very different world and a very different scenario that we'd be looking at in 2100. When we're dealing with this kind of uncertainty, this is the area where it becomes complicated to incorporate climate change into disaster risk reduction and disaster risk management. But that's what we're going to get to later on when we talk about the tools. For now, let's look at how climate change actually starts to affect our society. We start off with greenhouse gas concentrations that lead to climate change, global warming, and other variability in the system. These lead to impacts on our society and our operations. And we can respond. We can respond in 2 different ways, either through mitigation, which in this context means reduction of greenhouse gas emissions. That actually stops the cycle at the beginning. Or we can respond through adaptation, which tries to address the impacts of climate change and is more similar to risk mitigation. Today, we're going to be talking about the adaptation and risk mitigation, and not about the greenhouse gas reductions. Disaster risk reduction and climate change adaptation are very related concepts, but they do have some differences. Climate change adaptation is designed to respond to gradual changes in climate conditions, but also to changing patterns, intensity, and frequency of extreme events, and to the ecological responses that occur to these changing conditions. Disaster risk management, on the other hand, has a broader mandate, and it responds not only to the climate and weather-related events and their ecological responses, but also to geophysical events, such as earthquakes, volcanoes, landslides, and even other, what we have formerly called man-made disasters, such as technology and terrorist activities. What we're going to be talking about is the intersection of the two, where they talk about changing patterns, intensity of extreme weather events, and ecological responses. And today, primarily, we'll be focusing on the climate and weather-related events and how climate change may affect these kinds of natural hazards. Let's start with a theoretical model of how climate change leads to changes in natural hazard exposure and risk. To begin with, we have greenhouse gas emissions that are rising in atmospheric concentrations. These lead to rising air temperatures, also ocean temperatures. They also lead to ocean acidification, which we will not be discussing much today, but also has consequences for ocean conditions. These lead to further changes in both the local average climate and also in the risk of extreme events occurring. We'll discuss this a little further in a few slides. These lead to a change in the exposure that communities experience in terms of these natural hazards and extreme events. But they also have consequences for vulnerability, for the socioeconomic conditions of the community and for the natural resources that are available. And this combination of the changing vulnerability and the changing exposure together leads to the change in impact and risk. In this way, the greenhouse gas emissions that we worry about for climate change eventually lead to what disaster risk management professionals will recognize as the classic ingredients of increased risk. To look a little further at this and to discuss how this leads to climate change adaptation and disaster risk reduction having different focuses, let's look at this in a different way. Here we have an axis with an environmental condition, for example, rainfall, and it occurs over some period of time. We see the seasonal variation or the interannual variation. Some years are wetter, some years are drier. But we have a coping capacity so that normally we can handle the increased rain or the decreased rain. It doesn't affect us on a disaster level. It's when we get these extreme highs or these extreme lows that we see drought or floods or landslides and other consequences of these extremes that are outside of our coping capacity. However, we see this trend in climate change that's increasing our rainfall in this area as we start to see these disasters occurring more frequently. What happens then is that as this increases, you see more disasters occurring and more variation. What we need to have happen at that point is to have disaster risk reduction activities or climate change adaptation activities occur that will increase our coping capacity so that we can handle these new levels of variation in the system. Now, what's important here to notice is that this doesn't occur once and then stop. It continues on throughout the time series, so that climate change adaptation and disaster risk reduction have to be ongoing activities. They have to continually occur throughout the system. And this continual need to occur means that there's an increased focus on flexibility and the adaptive capacity of the system, the ability of our society to do these repetitive disaster risk reduction and climate change adaptation activities. Now let's discuss some of the actual impacts that climate change is expected to have on potential natural hazards and their conditions. Most people are familiar with the slow onset changes that climate change is going to cause, such as sea level rise. Here we see, for example, how different greenhouse gas emissions scenarios can lead to different sea level rise scenarios. The more we emit, the more sea level we expect to see occurring. This leads to different predictions on how much sea level rise we will see. In a low emission scenario, we see on the order of 28 to 61 centimeters, whereas in a high emission scenario, we can see 52 up to 98 centimeters. And really extreme conditions, such as the breaking off of the Antarctic ice shelf and the melting of all the glaciers on Antarctica and Greenland, we could see up to 7 meters. But this is a really extreme scenario, and not one that we're likely to plan for in most disaster risk management scenarios. In the causes of sea level rise, I want to note here is not the melting of the polar ice caps, as some people often talk about. It's not the melting of sea ice. Rather, the primary driver of sea level rise is actually thermal expansion. Simply, as the sea water warms, it expands and gets larger, so that we have an increase in sea level rise. Adding to the complications of sea level rise, however, we also have subsidence, especially on megacities, on coastal areas. As these cities subside and the sea level rises, we have an even greater threat of potential flood in these areas. As an example, Jakarta, Indonesia sank over 4 meters over a 35-year period, which causes an extreme change in that ratio of sea level to ground. Sea level rise can also have other consequences, though, beyond the flood that we normally think about. For example, as sea levels rise, they can intrude into the groundwater. This can not only reduce the available drinking water that we might be using from that groundwater source, but it can also have detrimental effects on any coastal agriculture, as the salt water can be damaging to coastal plants and agriculture. Slow onset changes in climate change can also lead to changes in the frequency and severity of extreme events, as I can illustrate here. Here we have a graph that shows an old climate scenario, distributed as the probability of a certain event occurring at a given temperature. We're using temperature here just as an illustration. This could be any sort of weather pattern. So for the most part, you see that we have an average temperature most of the time. And at the outliers, we have a few extremely cold days and a few extremely hot days where we have these heat events. What happens, though, when we add in climate change? We add in this adjustment in the average. It can be a small adjustment, for example, in the order of 2 degrees Celsius that we expect to see. You increase the average conditions, but as a result, you get more hot weather, extremely much more frequently. And also you get this area here, which is new, record hot weather. Weather that is so hot it has never been seen under the old climate conditions. This has really significant implications for talking about heat wave and other climate scenarios we could put into the same kind of change. One other reason climate change is a problem in this scenario is I've illustrated it here as though the bell curve has simply shifted a little bit to the side. But we're not sure that's necessarily what's going to happen. The bell curve could shift, but it could also flatten out so that we get even more extreme events on either end. Until we see how that pattern is going to change, all we know for sure is that an increase here means much more extremes on the end. We can see this using an example of Quezon City and the projections. We start off with the climate trends, and we look here and we can see that in March, April, and May, in the observed period from 1971 to 2000, we have an average temperature of 28.8 degrees Celsius and an average rainfall of 199 millimeters. Looking out to 2050, it doesn't increase that much. We only go up to 30.9 degrees Celsius, and we reduce to 122 millimeters of rain. But what happens when we look at the extreme events that occur? Here you can see the number of days that are over 35 degrees Celsius has increased from 36 days to 104 days. This means that in 2050, 1/3 of the year is going to be over 35 degrees Celsius. And it's likely that some of those days are going to be extremely hot, more on the order of 40 degrees Celsius or more. So as we look at this small change in the average temperature leads to this rather extreme change in the potential for heat events. Similarly with rainfall, the number of days where we had more than 2 meters of rain in a single day was 9 days over the past 30 years. But looking out to 2050, over a 30-year period, we expect that number to double to 17 days. As that number doubles, we also need to consider the risk that has for flooding and for landslides and other events that might occur due to this extreme rainfall and very heavy events. So I just want to reiterate again that even these small changes in the overall climate change pattern have significant consequences for the natural hazards that occur at the extremes. This one is a fun pattern that I've always found very intriguing. Climate change is also going to lead to an increase in variability and to changes in the patterns that we've been used to seeing in our rain, temperature, and other climate conditions. So here, the United States National Oceanographic and Atmospheric Administration, NOAA, has projected that climate change is likely to cause a decrease in the number of light rain events and an increase in the number of heavy rain events. Now, light rain events are the kind of rain that is absorbed by the soil and is beneficial to agriculture and plants, whereas heavy rain events are the kind that often just runs off the soil and causes more flooding and damage. So as we decrease the number of light rain events and increase the heavy rain events, we actually end up with the somewhat ironic and counterintuitive situation where we have both more drought and more flooding. So climate change can have consequences for the frequency and severity of events, but it could also change the pattern of these events and how they occur. This change in the frequency and severity of floods and droughts can have consequences for floods, obviously for droughts, and for landslides, but it can also have major implications for water security. As an example, in Metro Manila, the Engot Dam supplies more than 90% of the drinking water from Metro Manila. However, the dam also supplies water for agriculture in the region, and for the production of electricity through hydropower at the IPO dam. When the region experiences a shortage, as it did in 2010 and as it may in 2015 due to a strong El Niño year, decisions have to be made about whether to continue the supply of drinking water to Metro Manila or whether to continue supplying water to agriculture or to electrical production. Stopping water to the agricultural region affects livelihoods on the order of billions of Filipino pesos, whereas of course cutting off drinking water to Metro Manila has major health implications for the city. Making those decisions is going to become more complicated in the coming years as the pattern of rainfall upon which the system relies becomes more variable and less predictable. Preparing for this infrastructure requires us to make decisions now about how we expect to look in the future. For example, should we start to develop new water sources for Metro Manila? And if so, how far in the future do we need to plan for those? It's unlikely that we can build a new dam and a new water source in a year or two. So how much lead time do we need to think about in advance those solutions before they're desperately needed? Another area that climate change may be affecting natural hazards is in typhoons. And this can affect typhoons in several different ways. To begin with, there are stronger winds. The World Meteorological Organization estimates that winds in typhoons will increase 1 to 2% for every degree Celsius that the world warms, leading to the conclusion they'll increase by 10% in 2050. Now, a 10% increase in typhoon wind is not necessarily catastrophic, but it does make us start to think, when we're building buildings right now that we want to be able to withstand typhoons, should we perhaps add on a 10% or greater safety buffer to account for the stronger winds that we might experience in the future? Climate change may also affect typhoons by increasing the amount of rainfall that we see. As the ocean temperature warms, it adds more energy into the system, which can lead to greater rain collecting in the clouds and lead to greater rainfall. Typhoons can also stay for longer and have longer duration. This means that where a typhoon may have stayed over land for a day or two, it may now stay longer, causing more damage as a consequence. And we'll see higher storm surge, which is a function both of the higher rainfall and also the higher sea level rise that we saw previously. Storm surge has particular implications though. It's not just like normal flooding. The higher storm surge, because it has a velocity, can also cause extreme damage from the force of the waves hitting buildings and things along the coast. So we have to prepare for that kind of damage. And finally, climate change can affect the actual paths of the typhoons and where they come. As an example, in the Philippines has been used to seeing typhoons in the northern region, but now we're starting to see them come in the south, as we saw with Typhoon Bopal. As new areas are exposed to typhoons and the hazards that they bring, how to prepare these regions for the variability that they could experience. This is one of the major lessons of climate change. It's going to increase the variability in the system, so that looking at the past is no longer a guideline as we look towards the future. And we need to be able to predict and look at what these future scenarios might look like in order to prepare. There are other ways that climate change might be affecting us and our society. Examples include heat waves. In 2015 alone, heat waves in Pakistan and India killed 3,000 people. In 2003, in the Europe heat wave, they killed on the order of 30 to 70,000 people. Heat waves have major mortality issues. In the United States, heat waves kill more people than any other natural hazard. So they are an area that has not necessarily traditionally been considered by disaster risk reduction professionals, but needs to be considered in the future. As we build new buildings and new infrastructure, how are we going to be handling heat in the future? Climate change can also affect diseases. Having a warmer, wetter future means that the future will be better suited for parasites, bacteria, and insects like mosquitoes that bring dengue and malaria. How we address these kinds of increases in frequency of disease events and also new diseases emerging into new areas where they have not traditionally been seen will be a major strain on our health service providers. And we need to be able to prepare for that and try and think about how we might address those issues. Climate change can also have implications for air pollution. In warmer days, ozone is more present in the air, which can damage the lungs. And it can have implications for food security, as we've discussed through drought and heat and saltwater intrusion. Climate change affects a number of natural hazards. And for more details on how climate change is actually going to affect each of these, you can look at the Intergovernmental Panel on Climate Change and its report, particularly its summary report for policymakers, which will walk through this in a more understandable language. So now that we've covered a little bit how climate change may affect natural hazards that you're trying to manage as disaster risk management professionals, let's talk about 3 reasons why you should be trying to integrate climate change adaptation into disaster risk reduction. First, the changing risk profile. As we've been discussing, climate change is going to have significant consequences for natural hazards, for their frequency, their severity, and their pattern of occurrence. The future is not going to look like the past. This sounds cliche, but it's really important because traditionally the way that we plan for the future is by looking at our historic events, at our historic frequency, historic severity of natural hazards and other kinds of events. We plan for those. This no longer works in a world where climate change is continually changing the risk profile. And so we need to be able to try and look at how that risk profile might change and to preempt those consequences. Furthermore, retrofits are expensive and difficult. So getting it right the first time when we design a building that's going to last for the next 100 years is really important. Second, integrating climate change adaptation and disaster risk reduction can have significant benefits, can save time and money as the two have mutual benefits and synergies. As an example, planting trees for disaster risk reduction for flood mitigation can be very effective, but it can also help climate change adaptation as those trees absorb carbon and reduce the greenhouse gases in the atmosphere, reducing the overall climate change and reducing the potential impacts on the climate. As we think about these benefits, we also are able to leverage the systems, the funding sources, and the political willpower that exist on both sides, bringing them together to be able to support new and better projects. And third, we need to avoid maladaptation. And by this, 3 different kinds of maladaptation: spatial, financial, and carbon emissions. In the spatial, we don't want to see development occur in areas that are currently safe, but in the future may be prone to natural hazards. For example, areas that are safe now, but may be prone to more flooding due to increased rainfall or to sea level rise in the future. We also don't want to see financial investment in areas that make sense now, but might not under conditions of climate change. Another example is in the Philippines, looking at hydropower. Hydropower may be financially feasible right now, but as climate change affects rainfall in the future, hydropower becomes less financially viable. And it can change our priorities about where we put our finances and our money. And finally, with carbon emissions. Sometimes it's tempting to address a problem by using a solution that draws on carbon emissions and fossil fuels. For example, addressing heat waves by installing more air conditioners. However, as those air conditioners use electricity and draw on more fossil fuels, they create more carbon and greenhouse gas emissions, which leads to more climate change, which leads to more heat events, which causes more of the problem that we were trying to solve in the first place by installing the air conditioners. By trying to avoid these problems, integrating climate change adaptation and disaster risk reduction in the same project can help solve some of these problems. We're now going to move to a question and answer period. I'm looking forward to your questions and discussion, and then we'll take a short break and come back for section 2. Thanks.